Hello everyone, we are discussing power in electric circuit. Look at this example. There is a bulb and it is given that at 220 volts its power is 100 watts. The old bulbs with filament and all, you must have seen those bulbs. And on top of the bulb, you would have seen this kind of rating, 220 volts, 100 watts. So this is a standard reading. When it was manufactured at the company, then they found that once you connect it across a 220 volt supply line, the brightness, or you can say the power it consumes, is 100 watts. Now, but when you connect this bulb to a 100 volt supply, question is, what will be the new power output? Let's call it standard voltage V0, standard power P0. V0 and P0, these are the standard values. If you connect it across a 220 volt supply, you will get 100 watts. But back home, when you connected it to a 100 volt supply, then what is the power output which you will see? This is the question. Let's see who can answer this question. We've got 30 seconds time. The only hint is this. P is VI V square upon R I square R. And you can answer this question. Let's see who can. Well, I've got only one answer, and that is also not correct. I'll give you a hint. Tell me first, there are things like potential difference, current, resistance, power. So when you connect this bulb to a different voltage supply, what is that which is not going to change? Answer this thing first in the comment box. What do you think? Resistance, current, potential difference. Which one will remain same? Good. Now you answered correctly that it's the filament inside. Hopefully you have seen a filament like this inside. And this filament is something which is offering a resistance R, and this R will remain same. Resistance will not change. We can design questions in which resistance can also change. Why? Because as temperature changes, resistance changes. But right now we are not interested in that profile. So although potential difference across the terminals of the bulb, you are changing that, that will result in change in temperature, but we are not assuming any change in the resistance because of that. Now, the answers which you have produced so far, you did something like this. Now, the logic you're using is 220 volts is giving us 100 watts, and therefore 1 volt will give us 100 upon 220, and therefore 100 volts will give us 100 upon 220 multiplied by 100, which is the one you have produced, 500 upon 11. Some of you answered this, which is wrong, because it shows a linear relationship between voltage and power. This type of thing is valid for linear variation. Linear variation means if you say that P is proportional to V, then you can use this argument. If so, those of you who answered this thing, those who did not, they can also write like this, make a cross and mention that this approach would be correct if P is proportional to V. Now, when will P be proportional to V? If you say P is proportional to V, then I, current, must be same. So this is correct if I is same. But for the given question, as you change the voltage, current will change, power will change, but the resistance of the filament, it's not going to change. And if resistance is not going to change, then we cannot use this approach. So I'm giving you another 30 seconds. Now you know that R is same. The answer, what is the new power output? Even after giving this much hint, you find it difficult. Look, we have been given that R is same. Now for this question, if I say R is V square upon P, use this. What is R? V square upon P. If I use this, then I've been given voltage and power initially and finally. But for both situations, your R does not change. It means what? R initially, what is the voltage? 220. 220 square divided by the power, which is 100. Finally, the new voltage supply is 100. New voltage supply is 100 square divided by new power. This is what we need. Now this is 100, 0 square is 100, 100 and 100 cancel. And your new power is coming 10,000 divided by 22 square, which is 484. Resistance is something which is not going to change. Initial voltage, initial power, new voltage, new power. So new power is coming 10,000 divided by 484. Simplify it and you will get the answer. Those of you who could not answer it, but they now understand this part, along with this, write down yes in the comment box. And if you have any doubt still, you can switch on your mic or you can write it in the comment box. Excuse me. Look at this question. There are two bulbs, and this is a very good example for board examinations. There are two bulbs of 100 watts and 50 watts. These are the standard readings. They both operate at 220 volts. 100 watts, 220 volts, 50 watts, 220 volts. When you connect this bulb to a 220 volt supply, it will give you 100 watts. When you connect this bulb to a 220 volt supply, it will give you 50 watts. This device, these two bulbs are connected in series across a 220 volt battery. Brightness coming from this bulb is P1. Brightness means power output. Brightness coming from this bulb is P2. Which one is correct? P1 is greater than P2. P1 is less than P2, or P1 equals to P2. Which option is correct? A, B, C. Note down the question and answer this in the comment box. Well, everybody is answering A. I don't know why. Option A is not correct. What makes you think option A is correct? If everybody is saying A, it means one person answers and the rest they simply follow the same thing. Use your logic. The only thing you need is this. You can answer any question on power with the help of this. And I always tell you that Whenever they give you something like this, ammeter, voltmeter, bulbs, heaters, these things, for you they are simply what? Resistors. This circuit is equivalent to this. You've got two resistors R1 and R2. They are connected to a power supply of 220 volts. R1, R2. What is R1? This bulb. What is R2? This bulb. So treat these two like this. Now, if you've got R1 and R2, then tell me which power format you should use. That's how you answer, that's how you approach these things. Tell me this, which version you should use. P equals to VI, P equals to V square upon R, or P equals to I square R. To answer brightness, what is that which you must use to compare the brightness out of these three formats? 1 VI, 2 V square upon R, 3 I square R. Which one you should use? Answer this thing first in the comment box. And the hint is, look at R1 and R2 and the combination they are forming. Good. R1 and R2 are in series, and if they are in series, then they both have same current. If they have got same current, then if you want to compare power, they have same current. To compare power, therefore you must prefer I square R. For these two bulbs, current is same. If current is same, that means P is proportional to what? R. That's how we decide which format should be used. Now, the moment you decide that P is proportional to R, the brightness, the actual power, these are standard values of power. They are in series. This formula gives you what? Actual power. Now, so the actual power, you see, depends on what? R for this combination. Not every time, for this combination. Why for this combination? Because these two are in series and that makes current same. Now, the only thing left is what? Finding their resistance. So what is R1? R1 means resistance of 100 watt bulb. R100 means resistance of 100 watt. What is R2? Resistance of 50 watt bulb. So if you can find the resistance, the one which is offering larger resistance will give you what? More power, more brightness. Find out their resistance and answer the question now. Still taking time. You're not even ready to calculate the resistance part. How do you find resistance? For finding resistance of this bulb, a bulb whose operating voltage and power output at the operating voltage. Operating voltage means standard voltage is given. For finding resistance, we must use this P equals to V square upon R. If power and voltage are given, then for resistance, we must use this formula which says R is V square divided by P. This is for finding resistance. Resistance of 100-watt bulb therefore is what? What is the voltage? 220 square divided by power 100. This power, this voltage and this power will give you what? The resistance, because these are the standard powers. When at the manufacturing plant they connected this bulb across a 220 volt supply, power output was 100. That gives you resistance. When you go for R50, voltage is 220 divided by power, which is 50. Now, for the question, you don't have to simplify, you don't have to solve these things. You can yourself see that this is 100 and this is 50. That means R1 and R2. What is R1? Resistance of 100-watt bulb. What is R2? Resistance of 50-watt bulb. This is less 50 as compared to 100, and therefore R2 is greater than R1. From this we decided this, but we already know that actual power is proportional to the resistance, and therefore P2 is greater than P1. P2 is greater than P1. Third option is the correct option. Note down this, and if you understand it, then write down yes in the comment box. These are, you can say, standard powers. And this is the actual power which we are talking about. So only one person answered C, and rest of you were answering A, B, all these things. Now tell me, first thing, question says if you connected across 220 volt supply, it will give you 100 watts. That's the meaning of standard power. And we have connected the setup to 220 volt supply only. Company says that if you will connect it to 220, you will get 100. We connected this thing to 220, then we should expect 100 and we should expect 50 from this. If this is 100, this is 50, then this one should give more power. Maybe that's why some of you answered B. So will tell me, why is it not giving us 100 watts although we have connected this thing to a 220 volt supply? Who can answer this? Well, nobody answered it correctly. This bulb will give you 100 watts when you connect it to a 220 volt supply, but you have not. This 220 will be shared by this bulb and this bulb. There are two resistors in series and you are giving them 220. Do you expect that it will get 220? No. This 220 will be shared by R1 and R2. And that's the reason you do not get these standard powers. Since none of you could answer it, write down this also as a statement. Although both bulbs are connected, to a 220 volt supply, but since they are in series, this 220 volt will be shared by both bulbs. This 220 will be shared by both bulbs. And because of this, we cannot expect 100 watts and 50 watts from these bulbs. And because of this, we cannot expect 100 watts and 50 watts from these bulbs. Now that will be the next thing. When you connect a 100 watt bulb and a 50 watt bulb to your household supply, you must have seen that this one will produce more brightness. But over here, what do you see? It is telling you that power of 50 watt is greater than the power of 100 watt. But when you connect this thing to your household circuit, you always see more brightness coming out from this than from this. So what is the reason? What is the reason behind this? Can you answer it? If you can, then write it in the comment box. Good. The household supply, things are connected in parallel and things are not connected in series. The bulbs, fan, AC and all these things, they are connected in parallel. Reason is, if they are connected in series and one of these does not work, so if you remove it, if it doesn't work, current cannot pass through it, then the second thing also becomes what? Useless. And therefore, in household supply, you will find that things are connected in parallel. So if things are connected in parallel, then it will look like this. If you connect these bulbs in parallel combination, to a power supply of 220 or whatever, it doesn't matter. This is your 100 watts, 220 volts. This is 50 watts, 220 volts. This is P1, this is P2. Standard power, 100 watts, it will come if you connect it to a 220 volt supply. And that's what we have done. So in parallel, it's not about this 220, had it been 100, 75 or anything. If they ask you find out relation between P1 and P2, now for comparing power, you will be using this second format. These two bulbs are connected in parallel. If one of them doesn't work, the other one is still connected to the power supply, and therefore things are connected in parallel. So, just to make the point clear, I am removing this 220 and I am replacing it with 100 volts. It doesn't matter if you connect it to 220 or anything else. These two bulbs, they will not give us 100 watts and 50 watts. It will give us 100 watts when it is connected to 220, but it is not. But still, if you want to compare P1 and P2, the actual powers, you will be using this formula. P is V square upon R. P is V square upon R. For this question, P is now inversely proportional to R. For this one, P was proportional to R. For this, P is inversely proportional to R, and therefore, since R1 is less than R2, this is something which is not in your hand. This is based on the filament. This is based on this. We have found the value of resistance using standard values. So R1 is still less than R2, but this time power output is inversely proportional to R. Therefore, P1 will be greater than P2. What is P1? 100 watts. What is P2? 50 watts. And therefore, for household supply, you see more brightness coming out from this bulb. Put on this as the second part of the question. Those of you who have seen the lecture on potentiometer, write down yours in the comment box. Now those who have not seen, can they tell me the reason why they could not see the lecture? Was there any specific reason that you could not watch it? Because I'm going to make it private and you won't be able to see it now. So if you had a valid reason, then give me the reason now. Look here. There are two heating coils, simply heaters, and these heating coils, they are of same resistance R. Two heaters of same resistance R. Just to simplify the question, we are taking same resistance. Once you see the concept, you will be able to handle any type of combination. It is given that when you use these heaters in series, across a given voltage supply, you can boil a given amount of water in, let's say, 10 seconds. The question is, when you connect these heaters in parallel combination across the same voltage supply, then in what time same amount of water can be boiled? Write down the question. Two identical heaters, when connected in series, can boil water in 10 seconds. Find out in what time same amount of water can be boiled if they both are connected in parallel across the same supply voltage. Across the same supply voltage. You've got 1 minute's time. Let's see if you can answer it. The only hint is the brightness part which we are using so far. For heaters, it's the heat which is coming out. More heat means more power. Only two responses. Look, how do you answer this question? First, tell me what is that which you have same in this? Same amount of water. If you want to boil it, what is that thing which you need which is same in this question? Suppose you have some water in a beaker and you connect two heating coils. For you, these heating coils are simply resistors, remember. For us, these things are resistors. And you connect this thing to a voltage of V. Two resistors, two heaters, and they are boiling this amount of water. And then what you did, you have taken same amount of water, but this time you have these heaters in parallel across the same voltage supply. That's what the question says. If you want to boil same amount of water, boiling is this M S delta T plus M into L. Coming from 11th, you don't need these formulas and all. Just to give you an idea, mass, specific heat capacity, delta T, change in temperature, mass, latent heat of boiling. That means all this has nothing to do with resistance, voltage, current and all. That means if you have got same amount of water and you want to boil it, then in both cases you must have same heat. Heat requirement is same for both heaters. This is the first observation. You don't have to have this much information. This is something which is quite logical also. You have been given two identical beakers, two different instruments to boil the water. If you want to boil it, you must have same heat. Now, this power formula, the power which you are using, if you remember, this power was dW by dt, rate of doing work. That's how we define power. But this work which is done by the voltage supply, work in moving electrons, which is done by the voltage, is not getting stored in the resistor. If you have capacitors, what they do? Capacitors, they store some amount of work in the form of electrostatic potential energy, and rest of the work dissipates in the form of heat. But resistors, they cannot store work in the form of potential energy, and therefore whatever work is being done is converted in the form of heat, and therefore for heaters, for bulbs, you can say that the power which is rate of doing work dW by dt is same as rate of heat generation. Write down this statement first. For a resistor, as there is no meaning of potential energy, for a resistor, as there is no meaning of potential energy, whatever work is done in moving electrons through it eventually comes out in the form of heat. If you remember the mathematical model of Ohm's law, there I defined things like these. Electrons, they are moving, they are hitting each other, and upon the collision, they are releasing what? Heat. That loss of energy is nothing but dH by dt, giving us power. So, once you have P equals to dH by dt, we can, for the given profile, take it as H upon T. You will take dH upon dt when you have to have differential formats and all. But right now we are interested in what? H upon T. Simply dH is H, dt is T. We'll be using this. P equals to H divided by T. Now, this tells us what? This tells us that H is P into T. If H is P into T, then look here. H, heat, is same. So product of P and T should be same. For questions like these, remember this statement, that product of power and time, it will be same. You can write as a statement again, for given type of questions, this will save you time. As a trick, you are noting the whole statement. You need to note down the whole thing. For the given profile, for the given question, product of power and time will be same. Now, you've got two resistors in parallel, you've got two resistors in series. For finding power, which format you should use? First, second, third. I mean, you can answer with the help of all three. Let me tell you this, you can answer with the help of all three, but what is that which you should prefer? You can answer like this: for series, first, second, third; for parallel, first, second, third; or for both first, for both second, for both third. What do you think? Let me see. What is your observation? Which power format we must use in this question? And the only hint is, look at the figure. The figure which I have drawn, it tells you what we should do in this question. Look, you may think that these are connected in series, and in series sir told us that current is same. And therefore for this, some of you thought that it should be third. They are in parallel and therefore second. The point is, question says both systems are connected to same voltage. So we have been given voltage. If you have the idea, if you have the information of voltage being same, then you must go with the second part. P equals to V square upon R. Which means what? Which means for the series one, power. I hope you can understand this. Let's call it P1 V square upon 2R. R and R in series is 2R, voltage is what? V. So the power which is coming out, the heat which is being generated is this. For the parallel combination, power is what? P2, which is what? V square upon R and R in parallel gives you what? R by 2. So in series, the amount of heat which is being generated at this rate. In parallel, V square upon 2R. The moment you have decided P1 and P2, product is what? Same. Therefore, let's talk about the product now. P1 T1, P2 T2. That's how you answer this. Once you found this, PT is same, P1 T1 is P2 T2. What is P1? V square upon 2R. What is time? 10 seconds. What is P2? V square upon R by 2. That is 2V square upon R. 2V square upon R. Multiplied by T2. We are interested in T2. Now since we are interested in T2, V square R cancelled. T2 is coming 10 by 4 or 2.5 seconds. And only one person could answer 2.5 seconds. Now, just to explain this whole thing, it took me this much time. Otherwise, from now onwards, this type of profile for objective questions should be answered in just 10 seconds. I've been explaining this question for last 5-10 minutes, and now what I'm saying is you can answer this thing in just 10 seconds. look at the approach. What I told you is that power and T, this product remains what? Same. Power and time, this part is always what? Same. The moment you say PT is same, what is P? V square upon R into T. P is V square upon R T. Now, if they have given you same voltage, then you will write V square upon R. If they have given you same current, you will go for the I square R part. You start from this, P becomes V square upon R. It tells you, and I hope you can see that T upon R is a constant or same number. V is same. This is the shortcut part. V is same. So you realize that T upon R is what? Same. That means you are saying that T is proportional to R. T is proportional to R. For things like these, when you have same voltage, T is proportional to R. What is the resistance? 2R. What is the resistance? R by 2. What is the change? From 2R, if things are becoming R by 2, that means 1/4. 2R divided by 4 is what? R by 2. So if you are dividing R by 4, you must divide T with 4 also. What is time? 10 divided by 4. This is your 10 by 4. So don't forget to note down this. This is the way you will answer these things in any objective examination. And again, to answer the question in now 5 seconds, just 5 seconds, if you want to answer it, then you can remember like this. T is proportional to R for a setup like this if you've got same voltage. But then you're creating so many results. So what I suggest is remember this. P multiplied by T is same. Note down this and answer the last part of the question. Answer the last part of the question. If in the previous question power source supplies power source, if in the previous question power source supplies same current always, if in the previous question power source, the household supply, somehow you arrange it such that it supplies same current always, then find out in what time boiling of water will start. Let's see how long you take. The question is now these two in series in 10 seconds, these two in parallel in what time, and question is telling you that you have a source of constant current. Taking too long, although everything is in front of you. Your source is such that it gives you same current I. The source is such that it gives you same current I. If it gives you same current, what is P into T? P into T is always same. What is P? This time I will be using I square R because current is given same. I is same, RT, that means you're saying that product of R and T is constant. That means you're saying that T is inversely proportional to R. For this setup, T is inversely proportional to R. So if T1 is 10 seconds, let's be fast, T2, your resistance is 2R, which is becoming R by 2. What is R by 2? R by 2 is 2R divided by 4. So you are reducing your resistance by a factor of 4. Things are inversely proportional. It should become 4 into 10 and your answer is 40 seconds. This much time it should take to answer a question like these. If you understand this, then write down yes in the comment box and then you can leave.